Okay, we're going to talk about all the equations that we have so far, and we're going to run through those. And then I'm going to run through kind of what you missed today if you're gone, and then also what we're doing Friday. And I will be back on Monday to hopefully see most of you. Let's talk for a little bit about velocity. Velocity equals distance divided by time. And sometimes we use velocity average, which is a lot of times we talk about V1 plus V2 divided by 2. In other words, we're going this fast for a while, then we went this fast for a while. What was our average? As long as the time is pretty much in sync, we're okay. This equation, I would like you to remember that time is distance over velocity, and that distance is velocity times time. Okay? So, let's talk for a second about acceleration. Acceleration, wow, that was bad. Let's clear that. Watch this, this is kind of cool. There, look at that. Acceleration is VF minus VI divided by T. In other words, change in velocity over change in time. Now, one of the other equations that sometimes we'll ask is we'll say, oh, you know, something's accelerating for 5 seconds at this rate. What's its final speed? So what we actually end up solving for is VF. VF equals VI plus AT. Okay, VF equals VI plus AT. Now, one of the equations that sometimes you have to solve for is distance. And in accelerating bodies, that equals VIT plus 1/2 AT squared. Now, this is just the t squared, not the whole thing squared. So if we were going to do parentheses, we could do them like this. Okay? Now, a lot of times we start from a stop. So this is 0, so it's gone. And when that's the case, then d just resolves to 1/2 AT squared. Okay, hold on. Let me grab my eraser and make a good 2 for you here. Squared. Okay, now, if I was to solve this for t, I would multiply both sides by t. 2d equals AT squared. I would divide both sides by a. And so that would leave me at 2d over a equals t squared. So now square root of both sides. So t equals square root 2d over a. You want to write this guy down. It's a good one that comes in handy quite often. So we talked in class, for those of you who are gone, we talked about if something's on cruise control, in other words, the speed's not changing, the graph looks like this, and then the distance time graph looks something like this. And we talked about if I multiply velocity by time, the area underneath this graph, the area underneath, is actually distance. Because we have an equation that says distance equals velocity times time. And we talked about this one where the slope is velocity. Because rise over run, d over t, equals v. Now, finally, we did a couple example problems, easy ones. I'm going to do one here that is okay. And what we're going to do is we're going to have a car, okay, and the car is starting from a stop. Here's a stop sign, okay. It's going a distance of 100 meters, okay. It has an acceleration of 3 meters per second. And I want to know some things. I want to know the VF at 100 meters. Okay. Yeah, let me erase that quick for you so you don't get confused. I want to know at this point, 100 meters away, I want to know what's the VF, and I want to know how long is this going to take. Well, let's write down what we know. We know acceleration is 3 and we know distance. So if we look at our VF for an accelerating body, starting from a stop, VF equals VI T plus AT. This VIT disappears because we're starting from 0. So VF equals AT. I know A, I don't know T. I know D. So remember our equation that we just talked about. The square root of 2D divided by A equals T. If I solve for this, I can move it in here and get two of my answers. This is this answer, and this one will be this answer. So, square root of 2 times 100 divided by 3. So 200 divided by 3 is roughly what? 66.7, something like that. Let's get a calculator out and solve this out. I don't know if it'll let me do this. It will, but it's got stuff written all over it. I'll do it offline here, and you'll just have to trust me. So if we go on my calculator, got to find my calculator, so just hold on a second. Here it is. I go 2 times 100 is 200. 200 divided by 3 is 66.7. The square root of that number is 8.16. So the time is 8.16 seconds. That's solved. So for up here, I've got 8.16. Now I need to get AT. 3 times 8.16 times 3 equals 24.5. 24.5 meters per second. So, car was at a stop, moving acceleration was 3, distance was 100. We wanted to know what was the final velocity after 100 meters and how long did it take to do that. And we solved them both. Solve for the time here, solve for velocity final here. Now, here's where we're going. Friday is a problem day. Okay? You will have a problem sheet. It'll say, I don't know what it'll say. It'll say Chapter 2 problem, something like that. You want to work those on your paper. Okay? Monday, we will be going over questions on those problems. Okay? And depending on how that goes, we will set our schedule. Tuesday looks like a short day, and we will probably hand out a practice test just to look at in class. I will probably do some of that solving, maybe over break, maybe not. No, I won't do it over break because I'll be on vacation. but on that Monday we get back, I won't be there, but we'll be wrapping some things up and doing some more problems. And then on that Tuesday, we'll get things organized, and we'll probably have a test that first week back after break. So that's where I think I am. So I will see all of you either Friday or Monday when you get back.